All right. Can you guys see my shared screen?
Yes.
All right. So it's essentially the same thing. Um, the reason why I don't do it that way is that I leave it for students to figure out on their own. Mine is to teach you the right way of doing it for the purpose of understanding, right? But um, as far as using number of teeth only, right, I leave it to students to figure that one out on their own. Right? Because once you understand something, you don't necessarily have to follow my guidelines. Right? If you happen to discover, um, say, a better way of doing things or another way of doing things that you resonate with, right, you're gonna use that. Why? Because you understand it. Right? It's like teaching someone how to use a sword. If I tell you never to switch hands while I'm guiding you or while I'm teaching you how to use a sword, the minute you are comfortable with using a sword, right, you obviously won't be necessarily following my guidelines. Right? When a scenario arises and you have to switch sword hands, you are going to switch sword hands. Right? Why? Because it is convenient for you in that moment. Right? Also because you know what you are doing. Do you get my point? Hello.
I hear you. I hear you. I hear you, boss.
Right. So let's look at this one, for instance. Okay, so this one we can't use because we
Sir,
number of teeth. Okay. Yes.
sir,
Let's look at
before
another one.
you close that one,
Yes.
if we are calculating, for example, on gear S, do we necessarily have to put maybe it's TA over times TC over TB and again because they both cancel each other and then we're gonna left with TA over TC? Is it necessary to show all four of them or I can just use two?
So it goes back to understanding what you are doing. Right? As long as you understand what
Okay.
you are doing, I am fine with that. With me, I show you all the basic steps because this is still a learning curve for you. Right. So for context, I'll show you I'll show you everything. Right. But sometimes not all the steps are necessary for you guys to show. Right. What we are marking here is understanding. That's it. Nah.
Okay, thank you, sir.
Right. This one. Right. Let's look at this one because we have all the numbers. All right. We can look at this one. We can look at this one. All right. Right. So the first one is obvious. In the first condition, remember you fix the arm and then you rotate the annulus by one revolution clockwise. So here I chose gear B to be my annulus. Now, if you look at gear B and C, they are fitted with the same shaft, right? Hence, I have them under one collar because the rotational frequency of this one will be the same as this one, seeing that they are fitted with the same shaft. So if I select gear B to be my annulus, And as per my first condition, the annulus is rotated by 1 revolution clockwise. It means if this is rotated by 1 revolution clockwise, this will also be rotated by 1 revolution clockwise. All right, so instead of having those two in separate columns, I just have them in one column because they are fitted with the same shaft. All right, hence I'm saying the arm and the annulus are obvious. Why? Because we are guided by the first condition, which says fix the arm, so that's fixed, hence it's equal to 0, and rotate the annulus. So the annulus here is B, hence I said, and rotate gear B, which I've selected as my annulus, by 1 revolution clockwise. All right. And then, of course, you look at which gear meshes with the annulus. The annulus here is B. B meshes with A. And that is why gear A is the next column here. All right. So now we are going to calculate the rotational frequency of A if the arm is fixed and the annulus has been rotated by 1 revolution clockwise. All right. Now, what we do is we'll look at the relationship between the two gears. By two gears, I mean the gear we're looking at, so gear A, and the gear it is meshing with, so gear B. The relationship between those two gears is that they are mesh. And if they are in mesh, it means the circumferential velocities of both these gears is the same. All right. If they are the same, it means VB is equal to VA. Maybe let's write it the other way around. It means VA is equal to VB. Right. And VA is equal to the rotational frequency of A times the number of teeth of A is equal to VB, which is the rotational frequency of B, times the number of teeth of B. Right, that is what this means. Right. Now, we are looking for the rotational frequency of A. All right. So the first thing you establish is the relationship which we have. The relationship between the two gears is that the circumferential velocities are the same. Next, you establish direction of rotation. Right. We already know that gear B is rotating clockwise. Right, as per the first condition. The annulus is rotating or has been rotated by 1 revolution clockwise. Right. Now, because B and A are meshing with the outside true circumference, it means when they rotate, they will tend to go in opposite directions. Meaning that if this, the annulus gear B, is rotating clockwise, it means gear A is rotating anti-clockwise, meaning that that's negative. Right? So because this is rotating clockwise, it remains positive, and because this is rotating anti-clockwise, that is why we insert a negative there. Right? Right, you insert a negative. That is the second step. So first step is establish the relationship between the two. This is the relationship. Next, you establish direction of rotation. This one is going clockwise, hence this one is going anti-clockwise. Next, you solve for what you're looking for. We're looking for NA. So you divide both sides. You divide both sides by negative TA. Negative TA. Obviously, that cancels that side. Then on the left-hand side, you're left with NA is equal to NB times TB divided by negative TA. Right. Now we want to get rid of this here. We want to get rid of NB, but instead of using this value we got for NB, which is 1, we want to express this in terms of number of teeth. Right. So you have to look at what else NB is equal to. Right. You look at what else NB is equal to. Right. Now, if you look here, let's see, you have NB. NB is meshing with this, but it's not meshing with anything else. So in terms of number of teeth, we cannot use that. NB. Let me just think about this quickly. This is not meshing with anything else. If this was the analysis, you'd have the analysis, you'd have P. That will be in terms of, okay. So this one is pretty straightforward because this is one, right? If you substitute one here, this will essentially be in terms of number of teeth. Right, so that one is pretty obvious. Let us look at gear D. Right. I don't know if you understand what I'm saying here.
Sir,
Yes.
sir, on the rotation, if it's cut like its side view, how do I see it's meshing outside or internal?
How do you see if it's meshing outside or internal?
Yes.
So if it's meshing outside, if it's meshing with the inside teeth, you'd have to get something like this. Something like this one.
Yes, I understand it when it's drawn like this, but when they give us a side view like the one that we were doing, that side.
This one. You mean like this
Yes.
one?
Yes.
Okay, let's see an example where we have the analysis and the side view. Oh yeah. This one is too obvious because you're given two perspectives. You're also given two perspectives here. Okay, you're given two perspectives here as well. I'm just looking for one where you're given just one perspective. I don't think I've ever seen one though. Maybe N4. Okay, not here. Let me just check in N4. Even this one. They're given two perspectives. Yeah. Or maybe this one is a bit better. But I've never seen one where you are just given one perspective. But if you look here, if you ignore this, right, if you ignore that, right, so this is the perspective you are talking about, right?
Yes.
Yeah, so I think it's clear from this perspective. If you're only given this perspective, the analyst will be drawn like that. Clearly showing,
Okay, that means it's internal.
yes, clearly showing that
Okay.
this gear is meshing with this one, and this one has internal teeth.
Okay.
Right, so it's pretty obvious on this one, but even on cases where it's not obvious, you are normally given two perspectives anyway, because even in this case, they gave you this perspective as well. But my
Yes.
point is, even if you're given this perspective, right, you can see that this gear is meshing with this one, right? Hence, for them to mesh, this would have to be using the internal true circumference.
Yes, I now I understand, sir, the difference.
Right. Okay, nice. Okay, let's go back to this. Right, this is what we're looking for. Looking at. Now, I said here for gear A, this is essentially expressing NA in terms of number of teeth, seeing that NB is equal to 1. Right, so essentially, if you substitute the 1 here instead of NB or in place of NB, essentially you'll be left with NA is equal to TB divided by TA. Do you see what I'm saying?
Yes, I understand that. But in
Right.
terms of gear
So,
D, it's gonna be a bit different.
yeah, let's look at gear D. So let's look at
Yeah,
D.
please, man. Let's look at gear D, see if it's the same answer.
Yeah, right. So gear D. All right. Gear
Yes.
D. Let's see. In terms of number of teeth, and see
So
what is.
that will be TB over TA times TA over TD.
It can't
So
be.
correct.
All right. So with this one, we can't express this in terms of number of teeth only. Why? Because gear C only meshes with gear D. It doesn't mesh with another gear. Right? Gear C doesn't have a relationship with another gear where the circumferential velocities are equal, just like it does with gear D. Right? So for this case, it is impossible to express this in terms of number of teeth only, because NC, or let me see, okay, I'm lying, because NC is equal to, okay. The only way we could do that is if we use the relationship between C and B, right? So in place of NC, we could have, yeah. So in place of NC, we could have NB. This is what I'm saying. You're saying that the two gears are fitted with the same shaft. So essentially, NC is equal to NB. Do you see what I'm saying here? Just in terms of these two
I'm
gears.
with you there.
All right.
Yeah, I'm with you
Right.
there.
So first step for gear D is you look at which gear it is meshing with. Gear D is meshing with gear C. So the relationship between the two gears is one of circumferential velocity. So ND, um, essentially VD is equal to VC. Right. The circumferential velocity of gear D is equal to the circumferential velocity of gear C. What is that equal to? ND times TD is equal to NC times TC. Right, that's the relationship between the two gears. Now you look at direction of rotation. Right, starting with NC, because we already have the direction of gear C. Right, how do we have it? We know that there is a relationship between gear C and B because they are fitted to the same shaft, meaning that if this gear B is rotating clockwise, it means gear C is also rotating clockwise, right? So this is rotating clockwise, hence it remains positive. But C and D are rotating or are meshing with the outside true circumference, meaning that if this is rotating clockwise, this is rotating anti-clockwise. So that is negative.
Anti-clockwise, yeah.
Yes. All right. Once you've established the direction of rotation, then you solve what you're looking for. We're looking for ND here, so you divide both sides by negative TD. All right. That cancels. Now on the left hand side, you're left with ND, and this side, you're left with NC times TC divided by negative TD. All right. Now we are saying we want to get rid of NC and express NC in terms of number of teeth. Now the only way we can do that here is by looking at the fact that NC has a relationship with gear B, and the relationship is that they're rotating at the same rotational frequency. Hence, NC is equal to NB. Right. So if we replace NC with NB, and then what is this? And then express NB in terms of number of teeth. Right. How do we do that? We look at NB. Right. We look at gear B. Gear B is meshing with A. So the relationship between A and B is NB times TB is equal to, what is this? Is equal to N, what is this? What is this? What is this? NA times TA, right? Then you're looking for NB, divide both sides by TB, divide both sides by TB, and then NB is equal to NA times TA divided by TB. But now you have to get rid of NA because we don't want to use this. Yeah, with this one we cannot express.
Yeah, that's one's a bit tough. You see, my reason for asking this question is in the textbook and in the memos of the question paper, I don't see them working out with in terms of N of the rotational frequencies. Like I only see them putting the number of teeth, dividing it, and timesing it by the next number, by other number of teeth. If you
So
understand what I'm saying.
yes, so those cases are typical cases of epicyclic gears where you actually have a ring gear, you have the planetary gear, and you have the sun gear, right? So the reason why I'm saying here we cannot use that is because if you look at the gears, right, the gears are only meshing with one gear, right? B is only meshing
Yes,
with
yes, yes.
C is only meshing with D, right? Now, in
Yes,
cases
I
where
understand there isn't a relationship between all of them.
exactly, right? Now, if you look at this
Yeah.
case, for instance, right, you have the analyst. The analyst is only meshing with the planetary gear. But if you look at the planetary gear, it's meshing with two gears. It is meshing with the sun gear and it is meshing with the analyst. Right? In this case, we would be able to express, for instance, um, for the sun gear, we will be able to express the
Yes,
sun
yes, yes.
in terms of number of teeth only. All right? Let us look at how. In fact, let's
Can
actually
we
look
do
at
that
how.
and see if we come up with the same answer?
Yes, let's do
Cool.
it quickly. All right. Firstly, okay, we are going to look at this one because we can't do it with gear P at this point because when looking at gear P,
It's times one, so it's gonna be the
right,
same.
time one, yes, but we can
Yeah,
do it
I
with gear
understand
C,
that. Yeah.
I mean with gear S. Right, so looking at gear S is only meshing with the planetary gear, so the relationship between them is NS times TS is equal to, and then the planetary gear is NP times TP, right? And then from here, because the planetary gear is meshing with the annulus, whichever gear that meshes with the annulus, right? When the annulus is a ring gear, right? The two gears tend to rotate in the same direction. Meaningly, if the annulus is rotating clockwise, then the planetary gear would also rotate clockwise. So that is to say that that's TP. That is to say that this remains positive because it's rotating clockwise, right? And then this will be negative because it's rotating anti-clockwise. If this is rotating clockwise, that's rotating anti-clockwise because the two gears mesh with the outside through circumference. And then of course you're looking for NS. So therefore you divide both sides by negative TS, right? And then NS will be equal to NP times TP divided by negative TS. Now, NP, right, gear P also has a relationship with the analyst gear, right? The relationship between the two is that the two gears are meshing. So NP times TP means that it is equal to NA, the analyst, times TA, right? The relationship between the two gears is this one. The two gears are in mesh, so their circumferential velocities are the same, right? Now this one, as per the first condition, is rotating clockwise, right? And then because this meshes with that, and this here is a ring gear, right? It means they are rotating in the same direction. So if this is rotating clockwise, that's rotating clockwise. Hence, it remains positive. And then, of course, you are looking for NP. So you divide both sides. You divide both sides by TP. That cancels, therefore meaning NP is equal to NA times TA divided by TP, right? And then of course NA is equal to, it's equal to 1. So it means you can express this as simply TA divided by TP, right? So NP is essentially equal to TA divided by TP. So you can take this and put it in place of NP. Right, so remember that this is what we got when looking for NS. Right, and then now we've established that NP in terms of number of teeth is equal to TA over TP. So now you can replace NP with TA divided by TP times TP divided by negative TS. All right, and then of course this and this cancels. So this is TA divided by negative TS. All right, that is how you do it essentially. All right, so to see if you get the same thing, the number of teeth of A is 100. So this would be 100 divided by negative TS, which is 20. So 20, which will be equal to negative 5.
-5.
Yeah,
Okay.
we've got the same thing. All right. So the reason why I don't teach students this is because there are scenarios where you can use it, and there are scenarios where you cannot, and you need to understand the scenarios where you can use it and the scenarios where you cannot.
Okay. Okay,
Right?
cool.
So instead of
And the
teaching
one
them,
that you taught us, that's for all scenarios that you can use in
again,
any scenario.
sorry.
As in the method that you taught us,
Yes, you can use in any
that can be
scenario.
used in
Yes,
all scenarios. Okay,
yes,
cool.
exactly.
Okay. Okay, cool. Thanks for clearing that up. I
All right.
appreciate that.
Yes, that's right, man.
Sorry for taking so much of the time.
Oh, this is what the session is for. You didn't take any time, Chief. This is what the session is for.
Cool, man. But I want to eat
Right.
this belt drives.
Sorry.
Nah, all good, all good. Carry on.
All good. Okay. Any more questions? Any more questions? Right. So if maybe you come across problems where maybe you're not sure of your solution, just holler at us in the group. Right. Even if I cannot respond, and whoever asks a question, you are able to give them a solution. Right. Do not wait for me. If you are able to help each other, then do so. Right. Because during the course of the week, I'm at Wingfield campus. So most of the time, I'm always busy while I'm there. Right, most of the time. Right, but I will be going on a 3-week recess soon. Right, I'll have a lot of time. Hence, I'll be uploading a lot of content for you guys. Nah. Now, before we adjourn the meeting, do we have any more questions? No questions.
In terms of the test,
Uh-huh.
so it's epicyclic gears and belt drives.
Belt drives, yes. Belt drives.
Are we going to go over belt drives today?
No, it's up to you. Remember, the video on belt drives has already been uploaded. So it's a matter of you going over it or going through it, taking down notes, attempting some exercises, and then if you do have questions, I can address them.
Okay, cool.
All right.
Can you give us some problems to work through? Some problems you think that, yeah,
Let me see.
on the level of the test we might be getting.
Um, are you guys still not on Moodle yet? Because there are questions here.
I actually done it today. I actually done it earlier. I got sorted with that today.
Okay. Let me just see if belt drives, video activities. Also, I sent you guys. I don't know how many question papers I sent you. I sent you question papers, right?
Yes, you did.
Right. So you can use that as well. But for belt drives, yeah, you do have exercises that you can go through, which are these ones here. But you can go through these exercises. Nah? And if you are lucky,
Okay, cool. I'll go through them.
you might see one of them in the test. If you are lucky. Yeah. So just do those. Let me just see belt drive solutions. So I did one or two. Yeah. So you have everything you need there. Right. So just go through the video, go through the activities. If you have questions, I'm available to answer those questions. And that's pretty much it. Conveyor belts you can expect in the second assessment. Right. But I guess we will speak about that in detail after your first assessment. No?
Okay, cool.
It seems you are representing the whole group today. A lot of people are quiet. Hopefully, that's good news. People being quiet. Any more questions? Wonderful. No questions. All right. You guys can spend the rest of your evening studying. Try to enjoy that, and I'll enjoy my evening as well.
Okay, cool. Cheers. Cool,
Cheers.
cool, cool. Cheers. Peace.
Thank you, sir.
All right. Bye bye.